Good evening, everyone. Welcome to this 5-day workshop on image processing using Matlab. Today is day 5. Today's topic is deep learning using Matlab. Okay. Before we go into the session, first I would like to welcome you for the session. Thank you for your time and thanks for coming today. I welcome the early comers first. Good evening, Sarath Kumar, welcome. Prashant, welcome. Nageshwara Rao, welcome. Harsimran Jot Singh, welcome. Lakshmi Priya, welcome. Rohit, welcome. Kalyan Kumar, welcome. Manoj Kumar, welcome. So, Sarath Kumar, yes, welcome. Adamu Bala, welcome. Gopi Sai, welcome. Snegal, welcome. Lakshmi Kant, welcome. Melandas, welcome. Sunil Kumar Bohra, welcome. Subrajan, welcome. Sushil Kumar Singh, welcome. Janvi, welcome. Word for Life, welcome. Okay, Ayush, welcome. Omoria, welcome. Balkrishna, welcome. Bonesh, welcome. Naveen, welcome. Banu, Rahul Kumar, Piyush, welcome to you all. Okay, welcome all. Okay, thank you for your time. So, with this. Okay. So today, I'll give a short introduction about Pantech and myself, and then we could go to the session today. At the end of the session, you will be receiving the certificates online. So I'll provide you the link so you could download the certificates today. Okay. And about Pantech, Pantech was started in the year 2004 by a team of 4 young people. We are basically into manufacturing of embedded motherboards. We manufacture various motherboards on microcontrollers like DSPs and FPGA boards. We manufacture. We also manufacture electrical lab equipments. We have renewable energy lab trainer kits and fuel cell trainer kits. If you want to know more about our products and services, you just log on to our website pantechsolutions.net. Okay. About me, my name is MK Jeevarajan. I completed my master's in the year 2004 from College of Engineering, Guindy, and my bachelor degree in Government College of Engineering, Barpur in 2002. So my primary expertise is on microcontrollers, DSPs, and FPGAs. I used to work on various controllers and DSP boards. I have worked nearly around 7 to 8 manufacturers like Atmal, Microchip, and Xilinx, Texas Instruments, and Altera. Okay. So this session is about sharing my knowledge with you. So if you want to connect me on LinkedIn, just send me a connection request. I'm happy to help to your questions and happy to connect. Okay. So I will give you a short disclaimer. Pantech is not associated with Matlab, and all trademarks used in this presentation and are owned by the respective owners. If you want to download the Matlab trial version, we have provided the link so you could download on the previous description box in the previous day. So today we have not provided the description for the trial version. We have not provided the link. Okay. So it's a 30-day trial, you could make use of it. So I have small announcement, the attendance form will be released at 6:30 p.m. and the certificates will be at the end of the session. Okay, so stay until the end and just collect your certificates. Okay. So today's session is deep learning using Matlab. So before going to the depth into deep learning, I will give you a short introduction about machine learning, what is machine learning. Okay, so if you take a normal program, if you take a normal program, I have taken an example called human activity detection. Okay, in this example, I used to get sensors values from the sensors, it may be a MEM sensors or it may be magnetometers or like that. So I will be having a simple while loop and for loop and if loop. So I will be getting the values from the sensors and I will produce the results based on the threshold or based on the conditions. The program will give you the output. Okay. Whereas in machine learning, what happens is you will be building the model and you have to feed the data. You have to feed the data to the model, and the program itself it will produces the code based on the data you provided. Okay, so the machine itself will produces the program for the data you provided, and it performs a task. Okay, so that is called machine learning. Okay, the machine itself will update the code, will update the model, and it optimizes for the task. Okay, that is called machine learning. The machine learns itself. Okay, the machine learns and machine writes a program itself. Okay. Okay, so deep learning. Coming to deep learning is a subset of machine learning. So if you take like if you take artificial intelligence, you have neural networks. It starts with neural networks, and then the complex of neural networks. Like if you have a deep neural network, then it is called deep learning. Okay, so machine learning. There's a difference between machine learning and deep learning. So machine learning, the feature extraction process is manual in machine learning, whereas in deep learning, the feature extraction process is automatic. Okay, so it's automatic. Like since it is manual, like you have to choose the right feature extraction technique in machine learning, whereas in deep learning, you just feed the data to the machine, and the machine itself will extract the features and it produces output. Okay, so the accuracy, if you check if you since it extracts the feature extractions automatically, since the deep learning extracts the feature extractions automatically, it needs more number of data. Whereas for machine learning, even if you have less number of data, and if you choose the feature extraction technique, right feature extraction technique, it produces the correct output. Okay, the accuracy you will be getting will be more on machine learning, even if you have less number of data. Okay, whereas in deep learning, you need to have more number of data because the feature extraction is automatic. Okay, so so better the model. So like deep learning. So since the feature extraction is automatic, the feature extraction depends upon the layer of the neural network. Okay, so better the layer, like better the model, then like more the data and better the model, you get better accuracy on deep learning. Okay, so if you take a few, if you have only few set of images, and if you want to implement the artificial intelligence, then it's better to go with machine learning. Okay, deep learning also has a solution for that. Okay, so if you are not like if you have more number of images and need more number of time, and you don't want to worry about the code or feature extraction technique, then it's better to go with deep learning. Okay, so if you take the if you want to, like if you take the deep learning architecture, okay, so this is the deep learning architecture. Like it has the input layer and the hidden layers and the output layer. Okay, the input layer will get the input, and the output hidden layer, like it will have more than one layer. Like it will have multiple hidden layers. Okay, so multiple hidden layers, and you have an output layer. Output layer will give you the class. In hidden layer, you will be updating the weights and the bias. Okay, each node is passed to the hidden node via a weight, and the node will also have a bias and an activation function. Okay, so during the training process, only the weights and the bias will get updated. Okay. So during the training process, only the weights and the bias will get updated, and you build the model. So if you give an unknown image, based on the weights and the bias, it will give you the final class. Okay. So if the output layer passes a feedback to the hidden layer, then it is called a feedback network, or a backpropagation network. Else it's a feed forward network. Okay. So far, if it is clear, like you just type clear in the chat box so that I could proceed, or else I will repeat. Is that clear? I'm waiting for a chat. So if it is clear, like the difference between the machine learning and the deep learning, and you just type clear in the chat box. Clear. Thank you, Abhishek. Thank you, Abhishek. Thank you, Ruchita Sinde. Okay, thank you. Hatim says to repeat. Okay, NS case, thank you. KGF, thank you. Vignesh, thank you. Nandini, thank you. Okay. Okay, so machine learning is done with both Python and Matlab. Which one is easy to understand? Okay. Clear. Okay, almost everyone is clear. Like Hatim says to repeat. Okay. So supervised learning. If you take supervised learning, like there are types of deep learning techniques. Like you have supervised learning and unsupervised learning, and ensample learning and semi-supervised learning. Okay. During the training process, you provide the output and you teach a system. Okay, you teach a system, then it is called supervised learning. Okay. For example, in this case, like you give a 1 rupee coin and the future and the weight is 3 grams, and you just tell the system like if the weight is 3 grams, then it is a 1 rupee coin. And if the weight for a 5 rupee coin, if the weight is 5 grams, then it is a 5 rupee coin. You just teach the system, okay, during the training process. Then it is called supervised learning. Based on that, it gives you the output. So when you give an unknown coin, like it check for the future. If the future is a weight, it check for the weight. If the weight is 3 gram, then it tells it's 1 rupee coin. If the weight is 5 gram, then it tells that it's a 5 rupee coin. Okay. So this is called supervised learning. Okay. For a child, you just show the photograph and you tell the child it is cat and it is a dog. And you teach the child by telling the child with the photograph and the class. Okay, dog and cat. Then it is called supervised learning. Okay. If the child learns on its own, then it is called unsupervised learning. So in unsupervised learning, in this case, we just provide the like if you take a cricket score and just provide the cricket score to the system clusters the data, like groups the data based on the runs and based on the wickets, and later you could name as those who are taking runs as a batsman and those who are taking more wickets as a bowlers. Okay, this type of during the training process, you will not provide the class, output class. You just provide you will be providing only the data based on the similarity of the features in the data. It groups the data. The system itself will group the data. Later you could name it. So this type of method is called unsupervised learning. Like the algorithm will be like clustering algorithms. Like you have fuzzy C-means algorithm or a K-means clustering kind of algorithm. So all these comes under unsupervised learning. Okay. For supervised learning, you will be having CNN algorithm, convolutional neural networks. All this comes under like transfer learning based pre-trained models. All this comes under supervised learning. So semi-supervised, it involves both supervised as well as the unsupervised learning. So you give supervised learning, then you ungroup the data, then you train according to unsupervised learning. This type of combining both supervised and unsupervised is called semi-supervised learning. Okay. And reinforcement learning, you have reinforcement learning, like you teach a system, like you give an image to the system. Based on the environment, the system will classify a class, and you have to reward, if it is correct, you have to reward with the system, else you have to tell the system it is an error. So this type of feedback based system is called reinforcement learning. Okay. So it is mainly used for robots, where the robot learns on the environment. Okay. When the robot achieves the goal, you have to provide a reward to the robot, and the robot learns based on that. If it does not achieve the goal, then you have to tell the robot it's false. You have to provide the feedback to the robot. This type of feedback based learning is called reinforcement learning. Okay. So far we have covered supervised, unsupervised, and semi-supervised, and reinforcement learning. Okay. And for ensemble learning, is like you could have multiple models. It may be a combination of both supervised as well as unsupervised method, or the reinforcement learning. So then finally, for the prediction, you will have a majority voting. You have a majority voting, and you will finally classify the class. So this type of having multiple models and going for prediction, instead of going with a single method, you go with 2 or 3 methods. So this type of method is called ensemble learning. Okay. So going through multiple models, and you provide the prediction based on the score. Okay. So far we have covered up ensemble learning, reinforcement learning, supervised, unsupervised, and semi-supervised learning. Okay. So deep learning, like there are data types like deep learning. You could use image for deep learning, like or video. Deep learning also accepts video. And signal, it also accepts signal, like ECG signal or EEG signal or any one-dimensional signal it accepts. And numeric data, it also accepts, and text data it also accepts, the natural language processing kind of thing like that. Okay. So these are the data types which could be used for deep learning. Okay. So you have to choose different network for different data type. Okay. So the data type may be image, video, or speech, one-dimensional audio, speech, audio, or ECG or EEG signal kind of signals. But there are different types of deep learning models. Okay, like if you take numeric data, or you could use machine learning or LSTM, long and short-term memory networks. Okay. For one-dimensional data like ECG or EEG or speech or audio or images or video, you could use LSTM or CNN, convolutional neural networks. Okay. Long and short-term memory networks or convolutional neural networks. For images, it's better to go only with CNN. Okay. For time series data, you could use both LSTM and CNN. For image data and video data, it's better to go only with CNN. So different data needs a different type of neural network deep learning architecture. Okay. So based on the data, you have to choose the right deep learning architecture. So if this is clear, just type clear the chat box. This is clear, just type clear in the chat box. Okay, so I will proceed. If this is clear, I'll go with the majority. Okay, I'm waiting for a chat. If this is clear, like give me a thumbs up so that I could proceed. Okay, just type clear in the chat box if we can proceed for the next. Thank you, Richita. Thank you, Hatim. Thank you, Suraj. Thank you, NSKs. Thank you, Ayaraj. Okay, thank you, Tritika. So coming to deep learning workflow. Okay, so coming to deep learning workflow, there are three steps. The first step is to prepare the data set. Okay, you have to prepare the data set, better the data, and better the accuracy. If you confuse the data, if you confuse the data, if the data preparation itself is wrong, then the accuracy will be low. Okay, for example, you take a child and you teach the child with you're showing a dog photograph and telling that as a dog. Again, you're showing the same dog photograph and you're telling that as a cat. Okay, so the child will get confused because it looks for the color, it looks for the size, it looks for the shape, and all the features are same. And it was trying to classify, like it was trying to distinguish. So if it was not able to discriminate the features, then the child will get confused, and it was not able to learn. Like it will give you only the misclassification. Similarly, for deep learning network also, like you have to provide the right data with right features. Okay? You have to provide the preparing the data set is a key thing, and then ground truth labeling. For example, you take an image, and if you are going to work for a pedestrian direction, okay, you have to tell the system what are the features of a pedestrian. At least you have to give, because the image will have the whole scene. Okay, when you take a photograph on the road, it also captures the car, it also captures the background image, it also captures the road, it also captures the building. Okay, you have to show you have to crop, and you have to tell the system this is the pedestrian. For pedestrian detection, for if you are going for a pedestrian detection or a vehicle detection, if you are going for a vehicle detection based deep learning technique, you have to just crop the vehicle and you just tell the system that this is okay. So this type of cropping is called ground truth labeling. Okay, so Matlab provides a separate tool for ground truth labeling, and then where you could easily crop the images and you could feed the data. Okay, so in preparing the data set, the first thing is to collect the data set, and second thing is to label the data set, ground truth labeling. Because if you are going for a supervised learning, you have to label the data. You have to tell the system which is pedestrian and which is vehicle. So this process is called ground truth labeling. Okay, and the second step in the workflow is the training model. You have to define the layers. And like you have to set the training options. Okay, like what type of method, what type of training you need, and what is the mini-batch size, and like what is the mini-batch size, and what is the epoch. Everything you have to feed to the network. So that comes under train model. Okay, defining the layers and setting the training options. And third is the deployment. Deployment is like You could deploy the system, like once the training process is completed, you could deploy the system either in a normal GPU or a CPU based on your laptop, or you could also deploy on an embedded GPU like a Raspberry Pi or NVIDIA Jetson Nano. You could deploy, or a FPGA. If you take FPGA like Pink FPGA, you could deploy that deep learning algorithms on that, or you could also have in the cloud. You just send the image to the cloud, and the image will classify and tell you the output. You get it from through an API. Okay, so you could have multiple deploying systems, like maybe it may be an embedded processor, or it may be a desktop or a laptop, or it may be on cloud. Okay, so this is the deep learning workflow. And coming to convolutional neural networks, okay, so this is the block diagram for the convolutional networks. In convolutional neural networks, you just take the image and you will be training the network. You will be having the layers. Okay, the layers will have, like, it starts from the image layer, input layer, and you will be having the hidden layers, and then finally you will be having the output layers. Okay, so image in convolutional network, the first layer is the image input layer, which gets the image as an input. Okay, not a feature. No need of any feature extraction technique like GLCM or wave transformation. No need of any feature extraction technique. You just directly feed the data to the system, image to the system. The image takes the input from the image input layer, resets to the network size, and then the first thing it will send to the convolution layer. Okay, in convolution layer, all the edge information it will extract all the edge information based on the filters you define. Okay, so more the number of layers you have, more the feature it extracts, and better the accuracy you got. Okay, and then after the convolution layer, the next layer will be the ReLU layer. The ReLU layer will act as an activation function. It will be acting as a threshold, and it tells the node whether to send the output to the next node or not. Okay, activation function. And the third layer is a max pooling 2D layer. Max pooling 2D layer, which is a downsampling layer, which will again extract the shape kind of information like that, which downsamples the data. And then finally it goes for a fully connected layer, softmax layer, the classification layer. Okay, so the fully connected layer will have you the class. For example, you take a cancer detection, you have only two classes. One is normal and another is the malign. Okay, a normal tumor or a malign tumor. Or if you could have three: normal tumor, benign tumor, or malign tumor. So in that case, the fully connected layer is 3. It will have 3 classes. If you are going to classify a dog and a cat, then the output class is 2. Okay, so the fully connected layer will downsample, like downsize, and it will have the number of classes. Finally, you will be having the softmax layer, the classification layer, which will give you the final class. Okay, so this is the block diagram for the convolutional neural networks. If you are clear with this block diagram, convolutional neural network, just type clear the chat box. I'll look for the chat. Deepali sir, thank you. Janani Periswamy, yes, it's clear. Thank you. Thank you. I'm waiting for a chat. I'll go with the majority. Okay. If it is clear, like, is it based on Nyquist theorem? No. Bubin Shahu, clear. Thank you. Shivam Gupta, thank you. Tejashwani, thank you. Sunil Kumar, Montu Patel, thank you. Sharu Priya, thank you. Shushri Panda, thank you. Arun not clear. Okay, one not clear is there. Okay. Tanu, thank you. Yash, thank you. Kapil Dev, thank you. Vivek, thank you. Sushil Kumar, thank you. So we have one more. Arun, you just please go through the video. It will be available. So the rest is clear. Okay. So you could also view the features inside the hidden layers, like the CNN. Like you could also visualize the features just by activating the layer activations and the class activations and the deep dream images. Okay, you could also visualize the features. So coming to the approaches of deep learning, like, okay, so we have two approaches. One is to train the deep neural network from the scratch, which requires hardware bandwidth, as well as it requires a large number of images. For example, it may require even 10,000 images or 20,000 images for training the deep neural network from the scratch. Okay, Else you could go with a pre-trained model. Pre-trained model, for example, if you don't have that kind of hardware bandwidth, if you don't have a GPU, okay, if you don't have a GPU or a cloud-based GPU, and if you don't have more number of images, for example, you have only 100 images for each data set, then you could choose the second option. You could go with the pre-trained model. Okay, there are a lot of pre-trained models available in the internet. You could download even Matlab supports nearly around 12 to 20 pre-trained models like AlexNet, DenseNet, and VGGNet, and a lot of pre-trained networks are there. You could download the pre-trained models, okay, and you could copy the weights, just copy the layers, modify the layers, then you could retrain the algorithm for your own application. Okay, so that will be that will work for the laptop. Even if you have a 4 GB RAM CPU, it will work. Okay, else you have to go with the training the deep neural network from scratch. Today program we are going to train a deep neural network from scratch, but since the features are clear, it will work. Okay, if you have a complex features like lung cancer detection or lung nodule detection, a kind of thing, then this building a deep neural network from scratch will never work until you have large number of images and you optimize the network. Okay, in that case, you just go for the second option. You go for the second option, copy the pre-trained model, modify the layers. Only the last two layers you have to modify. The fully connected layer and the classification layer you have to modify. The rest of the layers you just copy and update the weights for your own database. Then you could use it for classification. Okay, so that's a pre-trained model. So labeling, again, labeling is more important. So Matlab provides a tool called ground truth labeler, where you could import the images and you could label the data. Okay, so ground truth labeler, it is available on the app window. There are other tools like image labeler for audio signal, and for signal and audio, like it has an audio signal labeler as well as audio labeler too. Okay, so if you check, like for image labeler, you have to install the computer vision toolbox, and for video labeler, you should install the computer vision toolbox, and for ground truth labeler, you have to install the automated driving toolbox. Only if you have installed this toolbox, this labeler will be available so that you could crop the data. Okay, so for signals and audio, for one-dimensional signals, for EEG signals, and for speech signals, and for audio signals, like you could use an audio labeler. It needs an audio toolbox, and signal labeler needs a signal processing toolbox. Okay, these are the tools for labeling, like for labeling the data, like to crop the for if you take vehicle detection, you have to crop the image like this. Okay, you have to crop the images, and you should label that as a vehicle. Okay, so coming to the pre-trained models, like there are a lot of pre-trained models which are supported by Matlab. You could go to the add-ons package and you could download, like Inception, ResNet, VGG16, and SkewsNet, AlexNet, and VGG19. All these are types of pre-trained models which has been trained in the GPU, like a cloud-based GPU, for millions of images and for thousands of classes. Okay, so it is an optimized network. So you could copy the layers, and you could modify the layers, and you could use the network. Okay, so comparison with the pre-trained models, like if you check the comparison with the pre-trained models, like if you have a 4 GB RAM system, then you could choose AlexNet. Okay, if you have a 8 GB RAM system, then you could choose DenseNet, like will have more accuracy. So the x-axis is the GPU time or CPU time, and the y-axis is the accuracy. Okay, the best one is the NASNet, but it requires minimum 16 GB RAM system to train the algorithm. Okay, so Inception, ResNet, VGG16, GoogleNet, and ResNet. Okay, so coming to the deep learning on like CPU, if you have a GPU on your laptop, by default the Matlab itself will detect the GPU and it deploys the training on the GPU. Okay, if you have a cloud-based account, then you have an option to choose the cloud-based account, or if you have a multiple GPU, then there is an option to choose the multiple GPU. Okay, or if you have a parallel processor, then So there is an option called execution environment on the training options. By using this option, you could choose to what kind of, whether you are going with a cloud GPU or a local GPU, or a parallel processor or a multiple GPU systems. Okay. So you could also deploy the targets on like on a NVIDIA embedded processor or a Raspberry Pi board. Okay. So these are the few examples of deep learning. Like YOLO algorithm is there, like you only look once for traffic sign recognition. By using YOLO, you could do a lot of things like fire detection and like pedestrian detection and sign recognition, vehicle detection. So any kind of object detection techniques you could do with YOLO. You only look once. Okay. And semantic, there's a technique called semantic segmentation. It's a type of deep learning technique which is used for segmentation, like for self-driving cars. Like if you take self-driving cars, like to segment the routes, to segment the vehicles, to segment the pathways, and for that semantic segmentation is used. It is also used for tumor segmentation, for brain tumor segmentation on medical images. You could use semantic segmentation, and for hyperspectral images, if you want to do on the hyperspectral images and the SAR images, synthetic aperture radar images kind of thing, you could go for semantic segmentation. Okay. It works fine on them. Fine. And for signal classification, you could also use for signal classification like ECG classification or EEG classification or bird sound classification kind of thing. So all these are applications, and speech recognition also you could do. So today's lesson is we are going to have a lesson on gesture recognition using a simple CNN. First, I will explain you the code on the presentation. Then we can go for the Matlab, and we could open the Matlab and we could practice it. Okay. So in this, I have two gestures, 0 and 1. Okay, and I have displayed the images here. Like the first thing in designing a deep learning system is image data store. Okay. First, I will show you the database. I will show you the database first. Okay. So I have a data set here, day 5 demo. Okay. I have a data set here. So the data set contains of like zeros and ones. Okay. The data set contains of zeros and ones. So 0, this is 0. So it's very clear actually. So by usually it won't happen, like it won't have this kind of clear images. Like sometimes you will have a elimination problem or something, like the color will not be, will have a different color. Okay, this is 0 and this is 1. I have 40 images each. For each class, I have 40 images. I have a folder called dataset. In this folder, I have two classes, zeros and ones. Okay, zeros and ones. So the first thing is to declare an image data store. Declare image data store. First, you have to read the images. For that, you use a command called image data store from a folder called dataset, and include subfolders. We'll take the folders inside the dataset. Inside the folders, we have two folders, 0 and 1. Okay. So the label source is folder names. Okay, 0 and 1. It takes the label sources folder names. If you want to have a different class name, then just change the folder name. It will automatically get changed. Okay, in the program. So step 1 is to image data store. Step 2 is for splitting the labels. You have to split the labels for training. Usually they will be splitting for 3 kind of thing, like the training, validation and testing. But in this example, I have used only training and testing. Okay, I have used 90%. I will change and show 90%, 80%. But usually they use 70% for training. For example, you have 100 images. They use 70% of the 70 image for training process and 15% for validation. Okay, during the training process, which is not used in the training process, and 15% for testing. Okay, so this is how they split the images. But in our case, I have choose 90. I'll also show you for 70 and 60, like 70%, like 70% for training and remaining 30% for images for testing. Okay, you have to split the labels, 70% for training and 30% for testing. Okay, and third step is to define the layers. You have to define the like deep learning layers. Totally, there are 7 layers here. Like the first layer is the image input layer, 128, 128 of 3. It tells that it has 128 rows and 128 columns, and 3 is a color image. It accepts a color image. Okay. The second layer is the convolution 2D layer. Like it means like the 5,20 denotes that it's a filter size, and the regular layer for the rectification linear unit, and the max pooling 2D layer for downsampling. 2, straight, 2 is a filter, and fully connected layer, the 2 denotes the number of class. If you have 4 set of class like 0, 1, 2, 3, then you should change this value as 4. Okay, and softmax layer and the classification layer are the final layers. So these are all the layers. Okay, you have to define the layers, and step 4 is to set the training options. Step 4 is to set the training options. In training options, like you will be setting the like mini batch size, and what kind of training, SGD method or ADAM method, okay, stochastic gradient descent method or ADAM method, what kind of method you want, and the epoch size, like what is the epoch and everything. Okay, so these like the epoch, to know epoch, it has been covered up in the neural network session, but the neural network session is it will be it alone needs 1 hour of training for covering this, what is SGDM and what is epochs and what is learning rate, which I'm not going to cover up. You have to set the training options here and the epochs. Here you will be setting only 2 things. One is the epoch and one is the learning rate. I'll tell you like what happens when you change the epoch during the training process. Okay. And finally, you have to train the network. Train network is a command which train the networks. Okay, you will get the training graph. Then now the system is ready for classification. So once it's done, then you could classify for you could plot the confusion matrix. Confusion matrix will give you the accuracy. So this is to test the CNN. Like you could choose the image and you could test the CNN. Like your get file is used to get the file from the folder. Okay, strcat stands for string concatenation. Yesterday we have covered up this path name and file name. Okay, and read the image. Imread is a command which is used to read the image, and imresize is to resize the image to the network size. And classify is a command which loads the network and it classifies the label. Okay, so I will explain you on Matlab, so you will be clear once you go through the code. If it is clear, just type clear in the chat box. If it is clear, just type. Epoch is the iteration, like navigation. Like epoch is the iteration of like during the training process, it will update the weights. Okay, so it will the loop will get iterates till it gets optimized, till the error rate gets optimized. So the PPT will be uploaded on the Facebook group. Like so, I will convert for all the day 1 to day 5. I will upload all the PPTs. Okay. Okay, I'll go with MATLAB now. So I'm copying this. I'm copying this folder. Okay, I'll go slow. I'm copying this folder. I'm changing the path. Okay, I'm copying this folder. I'm changing the path. So edit to open a new file. Okay. So first I type CLC for clear screen and for clear for variable clear. Okay. CLC for a clear screen and clear for variable clear. So I type help image data store in the command window. Okay. Image data store. So I get a sample code here. Like I'm going to copy this code. Okay. So it involves capitalization. So I'm copying example 1. Okay. Data set. include subfolders. You have to give include subfolders. It involves capitalization. So I copy this first program. Okay. This is to bring for the next line, okay, to show you. Okay, this is, I'll show you what is there in IMDS. IMDS image data store, disp of, I just type disp of IMDS just to keep a breakpoint here. I just keep a breakpoint here and I click run button. Okay, what it does is, in data set, we have two folders, zeros and ones. Okay, 40 images each, 40. So totally 80 images there. If you check IMDS, like IMDS will read all the files. It creates a data store and it stores all the image location on the data store. Like if you check files, there are totally 80 files are there and their locations are there. Okay, their locations are there. So totally 80 files are there. The image data store gets the input, like it gets the input from the folder dataset and it reads the dataset and like it won't read the images. It stores a location. So whenever you want, you could read. So IMDS will contain all this. Okay. So the next is to split each label. So just type help split each label. Okay. Each label. So you get a sample code here. You copy this code. Okay. So I'm going to remove this one. So I'm going to put, this is 0.7. So it takes 0.7 for disp of, this will be this I'm going to use for train data. Okay. And this is the test data. I'm going to split the label for training. 70% I'm going to use for training and 30% I'm going to use for testing. So if you put 60% will be used for training. I'll check whether this function is working or not. Okay. This should be IMDS. Okay. Okay, it's working now. So I have split the data set now. So step 2. So the first step, we have read the image data store. The second step, we have split the labels. 70% for training and 30% for testing. Okay. And then we have to define layers. The third is to define the layers, define the neural network layers. I'll copy this code from the presentation. So totally 7 layers. So I paste it here. So we have defined the layers now. So data store, split the labels, and we have defined the layers. You keep a breakpoint and check whether the layers are there. Like, got the layers here. Okay. Then step 4 is to set the training options. You just type help training options, help training options. You will get a sample code. You could also go with the sample code. Okay, I have a sample code here. So I just copy the sample code. So I need plots. Okay, I just copy the sample code and I go with the sample code. Okay, training options. So first we have declared the image data store and then split each label. Third is the layers. We have defined the neural network layers, deep layers, and the fourth is we have set the training options, and fifth is a train network. Okay, just type help train network in the command window. You will get a sample. You just go with the sample code. Train network. Okay. So always use help command because it involves capitalization. So else it will show error. Okay. I will explain you the training. I will explain you the. So this. So the train network. Okay. You have to pass this options. This is the layers. So I am passing the layers here. Okay. And train data. I have to pass the train data here. I don't want this white track. So I'm passing training data, layers and options. Okay. Finally, I'm going to save this network. Once the network is trained, save network. So that's all. We have created the simple CNN. Let's train the network now. Let me check this one. Okay. So learning rate I will configure, let me check this one first. Okay, so it will open a pop-up with the training graph. You could, on seeing the graph, you could tell whether the system is whether it is working correct or not. Okay, so it should reach 100%. Like you have on the top you have accuracy, on the bottom you have loss. Okay, so this accuracy is going down. It should go up actually. It should go to the 100 and it should get stabilized at 100. Okay, then only like the training option is, you have set the right training options. If it is not going to the 100, then the next thing is you have to look to the training options. You have to configure the epoch. You have to configure the correct learning rate and everything. Even if you set the training options correctly, and if the graph does not reaches the 100%, like the accuracy does not reaches the 100%, then you have to you have to go for the layers and you have to modify the layers, because it has not you have not extracted the correct features from the network. Okay, if all the training option is correct and the layers is also correct, then the problem might be on the data set. Okay, so you have only three options. So if your deep learning network is not working, you have only three options to check. First thing, you check with the training parameters. What is the epoch and what is the learning rate and what is the mini batch size? You go through that and you fine tune that one. If it is not fine tuned yet, then you go for the layers, you increase the layers, or you go for the pre-trained models and you just verify. Even if you verify after that, then the next thing you have to come to the data set. Okay, come to the data set. Okay, so we have got the training graph. Let us check for this, and I'm going to copy the accuracy. I'm going to check the accuracy. So accuracy, I'm going to copy this graph and let me plot. Okay. So this should be the test data. So I'm copying the test data for getting this one. Okay, test data, and this should be the net. Okay, mini batch size. Okay, labels. Train test data. This should be the test data. Okay, so I copy this, right click, go for evaluate selection. Okay, so it shows 100% accuracy. It shows 100% accuracy. Like we have used 12 images for testing. The green color shows that it's correctly classified, and the red color shows it's wrongly classified. Okay, so this is the target class and this is the output class. It shows 100% accuracy, but it won't happen like, because we have a very clear data set. Okay, if we check the clear data set, like if we check the data set on zeros and ones, okay, it is very clear. There is no change and there is no confusion between zeros and ones. But this won't happen for each and every system. Like it may have some complex, some may have like will have the color variations, or some may have that. So in that case, obviously the confusion matrix, like you will not get you will not get 100% accuracy. Okay, then you have to increase the layers. In order to make the layers simple, I have put the data set as very simple. It's a pre-processed data set, so it gives accuracy as 100%. Okay, so in that case, you have to go for the layers. I will repeat the code one more time. The first step is to image data store. The first step is to get the image data store, which will read the data sets and include subfolders. Is to include the folder inside the data set. For example, if you have 10 class, then it will take 10 class. Okay, you have to modify the value here as 10. Fully connected layer is 10. Okay, it will include the subfolders, and the label source, it will take the folder names. For example, instead of 1, I want to give the text one, like I just rename, you just rename as OME, then it takes the name as 1. Okay, instead of numerically, if you want text, you just rename the folder name, because we have given label source as folder names. Okay, and split the labels. It split the label for 70% for training and 30% for testing. Define the layers. This is the first is the image input layers, and all these are the hidden layers, and this is the output layer. Classification layer is the output layer, and convolution layer, ReLU layer, max pooling, fully connected, softmax are the intermediate layers. These are all the hidden layers. Convolution 2D layers and ReLU layer is activation. It does the activation function, and the max pooling 2D layer and the fully connected layer. Okay. So, and then training options, set the training options, the type of parameter, like what mini batch size you want and what is the epoch. By default, if you check here, the default epoch is 30 actually. If you want to change the epoch, then you have to change options.epoch equal to, you have to give the value to increase the epoch. Okay. The training options, set the training options and set the train, and this is to train the network. Train the network. Here we split the labels to train data. Okay. And give the input layers and the options, training options. You save this to network. So this will create a net.mat in the file where you could use it for the other program. Okay, and this is to classify. I'll show you how to, for individual image also, I will show you how to how it classifies. But before that, I want to get a confirmation that if this program is clear, like if you are clear with this, just type clear in the chat box. Just type clear the chat box. Thank you, Anbin Matai. Thank you, Anbin Matai. Thank you, Shudha. Thank you, Shudha Dakshit. Thank you. Thank you, Yash. Thank you, Yash. Thank you, Snega Singh. Thank you. Yeah, just type clear in the chat box, or I will repeat. If you want me to repeat, just type repeat. I need at least minimum of 3 repeats to be repeated. Okay. So otherwise I will go with the majority. Clear. Thank you. Thank you, Bhupen Shahu. Thank you, Ruchita. Thank you, Harish. Thank you, Sahana. Akan Singh. Okay, no. Vijay, not clear. Okay. 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 Clear. Okay. Thank you. Okay. I will repeat. So we have 2 not clears. Like I will repeat for repeat once. Okay. It's very simple. You have only 5 steps here. The first step is to get the image data store. Okay. Get the image data store. First you have to create a folder. For example, you take dog and cat classification. You create 2 folders, dog and cat, and you put all dog images on one folder and all cat images on the other folder. Okay. Data set. So you rename the folder as dog and rename the folder as cat. You put dog images on dog folder, cat images on cat folder, and the image data store will read all the images. Okay, all the images. You take 100 images each, it will read all the images. The second step is to split the labels. Split the label. If you put 0.7 here, if I'm going to put 0.4 here, let us set the training graph now. Okay, I'm putting 0.4. It means I'm going to take only 30% for 30 images for training. Okay, 20 images, remaining 70% I'm going to use for testing. Actually, it should be 70 and 30, but we change to 30%. Split each level. Train data will be 30%, test data. And third step is to define the layers. Okay, you declare image input layer will get the input. This is the size of the image. If you check this folder image, the image size will be, it is 128 with and 128. If the image size varies, then you have to add an additional code to resize the image, all images. Okay. Convolution 2D layer. This is the filters which you use. The second in the CNN layer, actually this order is always same. They will have a repetition again and again. Like they will copy the code and again they will paste and change the filters. But it starts from the image input layer and it ends with the classification layer. Okay, image input layer. The next layer will be the convolution 2D layer and the ReLU layer. Maybe there will be interchange of ReLU layer, max pooling 2D layer, and others. Some other and few more layers are there. Like data augmentation layers, that you could add. Okay, for ReLU layer, so max pooling 2D layer and fully connected layer. For example, you have 4 class, then you change this value as 4. Okay, and softmax layer and classification layer. Okay, softmax layer and classification layer. And the fourth step is to set the training options. In training options, like you have to set the method like how to train. So this part is like you have to be very clear with the neural networks. Okay, and actually in previous Matlab masterclass session, like we have covered up a session called neural networks, where we have clearly show how a neural network works, like how neural, how an input layer, like how a mathematical, because all these are mathematical equation, only the weights will get updated, because this input and the weights can be represented as a matrix form, and you will be having only the matrix manipulations inside. So everything can be represented as as an equation, only the weights will get updated. Okay, so when the weights will get updated, actually there is a process like the way they update the weights, as well as the way they iterate, how long you have to continue the this loop. So that will be the epoch size. Okay, so these are all the methods. Like mini batch size is a method, batch method is there, mini batch method is there, and one more method is there actually. Batch size and mini batch, I forgot actually. Okay, and then it's a train network. Train network, you have to give the train data. You should not use the test data. You have to give the train data and the layers and the options. Let us check for the 30%. Let me show me the graph. Okay, so you have to save the network. That's all. So the training process is completed. Then you could use it for the testing process. Okay, so now let us check. Okay, it reaches the accuracy. Because it reaches the accuracy, that again it comes down. Okay, so now if we check the confusion matrix, let me check the confusion matrix. Okay, I'm closing the previous one. Okay, because the test data has test data. Input to be non-empty. Input to be non-empty. Okay. Mini batch size. Okay. Okay, I think it's not working. Not working for. There's something problem with that data set. Okay, totally 56 labels are there. Okay. Okay, there's a problem, something problem. Okay, we don't have time to debug this code now. Okay. So I will show you the single image, this, how to test the single image. Okay, I just copy this code. Okay. Map. We're running out of time. x2.n. Okay. So I choose an image here. Okay, it should be 1 on the title. Okay. We have to train it again. Give me a minute. So it shows error. Let's check for 6. Okay. Okay, I'll go for the chat. How to make train data? What is process? The split each label will give you the train data, like with your server. Like how to make train data? What is the process? How to make it simpler than before? Okay. How to load data? Recognition options. Okay. Okay. So now, okay, this is okay. I click evaluate selection. So I'll check for the confusion matrix now. It's 100%. Just check for the code now. X2. Okay. Low net.mat. Okay. So the output will be displayed on the title. Okay. 0. So the output is displayed on the title 0. Like I run the code here like 1. Okay. I choose 1. So the output will be displayed on the title of the image. Okay. I'll explain this code. This is to get an image. Okay. Cat for string concatenation of path name and file name. Read the image, resize the image, and classifies the command. You have to load the network, which was stored there. Load net.mat, which was stored in the training process. And I am say resized image, and this is the output, the label. Okay. So if you click browse and if you choose the input image, so if you check on the label, it will show you the output. So I have displayed that in the title of the labels. Okay. So if this is clear, just type clear in the chat box. Thank you, Aravind. Thank you, Pradeep. If this is clear, just type clear in the chat box. Okay, I'm waiting for a chat. Just type clear in the chat box. Thank you, Billy. Thank you. Snaggle, actually, you could get the PPT on the Facebook group. Okay, you have to join. If you have not joined yet, like I will provide you the group link on the chat box now. So I will update this on the group. Okay. So I have provided the group on the chat box. Mahendra Patel, thank you. NS Case, thank you. Jot Singh, thank you. Nandini Singh, thank you. Pondinesh, thank you. Jay, okay, thank you so much. Thank you. Okay. With this, I close this session. So we also have like I will take the Q&A. Okay. So before that, I will give a small like about the internship. I will tell you about this internship on Matlab. Give me a minute. So on day 5. Okay. Okay, so there is none. Okay, I think it might be in this slide. Okay, so we have a 30 days internship session. Like if you want to join on this internship, like these are the projects which is included, like image compression, segmentation, denoising, recognition and gesture recognition, augmented reality, steganography and cryptography, and semantic segmentation. Okay. So we got a lot of mails to extend the date. So the date has been extended till I think it may be tomorrow or Sunday. I'm not sure, but you may get an email from our team, like whether it is on Saturday or Sunday. Like if you want to avail the internship, you could avail the internship. Okay, the offer price will be $750, and it's very cheap only. Like if you want, you could avail. Okay, so we could have a Q&A session now. Like I will take questions. Can we get PPT of what is Jeet? Actually, it is in Facebook group. We have provided that in Facebook group. You just join the group and you could download. Okay. Thank you, Aish. Thank you. Thank you, Sharapriya. Thank you, Vijayalakshmi. Thank you, Shahu. Is there any questions I could address? Is there any pre-request for Matlab Masterclass, and which version of Matlab is? It's better to go with 2019, after 2019B, because it has like a lot of toolbox like machine learning, deep learning toolbox. Like we have got a lot of sessions on deep learning. 2 to 3 sessions are there. So all that's like was the latest version of Matlab. Like you just go with 2020A or 2019B. Dr. Krishma Desai, and there's the same code works to import videos too. Polish, you have to modify the code for videos. You have to modify the code for videos, and even this is a simple code. Like for complex, you have to rework the layers, and you have to rework the. You have to add a pre-processing step if it is necessary. You have to add a pre-processing step for the images. And I get that the lecture video did not run other videos due to some issues. Okay. So you have changed the train set percent of what would be the problem? Yes, another question. Yes, it would be a problem. How to make train data, which is process and Vidya Sagar, like how to make train data, what is process and how to make it simpler than before. Train data, how to make train data. I'm not getting your point clear. Okay. How to make train data. You're talking about the data set or what? Like how to make train data. Or you want to split the data. Actually, split each level commands to split the data set to train data and source test data. Okay. So data set you have to prepare. Like, I'm not clear with the question. Facebook group link is already provided. Facebook group link is already provided here. Like you could chat box. Okay. So any questions? I'll come down. Like any questions you have. Any prerequisites? No prerequisites. Like you could start from scratch. Okay. Thank you, Harshimran Jot Singh. Thank you. The certificates will be uploaded like the time is 7:06. Like it will be uploaded 7:10. Okay. Give me a minute. Let me check. Is that not? Give me 2 minutes of time. I will check. I'll check whether the certificates are there or not. Okay, give me 2 minutes. I'm checking the certificates. It's ready or not. Okay. Please do can start our next internship. The next internship is on like FPGA masterclass. We have 21-day internship program. Like it starts on Monday. You could join, and we also have Simlink 30 days. That will be on the next week, I think so. And we also have a machine learning workshop for 5 days on Python. You might have received the emails. Give me a minute. I'll check for the certificate. So the attendance form is, I'm going to close this attendance forms, because only if I close this attendance form, like I could generate the certificate. Give me a minute. Okay, so it will be on within, like, you'll be, the time is around 7:10, like you'll be getting around 7:15 or 20. Okay, so image labeled data set, can use of data sets? No, image label is just for labeling the data. Okay, so thank you, Rohit. Thank you, Rohit. Thank you. And you'll be getting the certificates within 5 to 10 minutes of time. I'm sure that, because like they are working on it, like they are closing the attendance form, and like it is an automation process, like it is an automated process. It will be uploaded, if everything goes well, it will be uploaded within 5 to 10 minutes of time. So thank you so much. Thank you for your time. Like thank you once again. Meet you in the next session. Until then, bye bye. Thank you.